So let's take the example of a block pulled by a rope. So along the y direction, the net force is 0, and so the normal force plus the y component of the tension in the rope minus mg is equal to 0, and this gives the normal force is equal to mg minus t sine theta. So the maximum static friction is equal to mu Sn equal to mu S mg minus t sine theta. And the force of kinetic friction is equal to mu Kn equal to mu K mg minus t sine theta. So if the block is still not moving because of static friction, then sigma Fx is equal to 0. And this gives t cosine theta minus Fs is equal to 0. And the block will start moving when t cosine theta is larger than mu Sn or mu S mg minus t sine theta, which is the normal force. And if the block starts moving, then sigma Fx is equal to ma, which means t cosine theta minus Fk is equal to ma. So t cosine theta minus mu k times n, which is mg minus t sine theta, is equal to ma, and this gives the acceleration of the block is equal to t cosine theta minus mu k times mg minus t sine theta over m. So now suppose that the tension in the rope is 8 newtons at an angle of 30 degrees and the mass of the block is 2 kilograms and the coefficient of static friction is 0.5 and of kinetic friction is 0.4. So will the block move? And from this equation you can calculate the minimum tension for the block to start moving, which is 8.87 newtons. So the block is not moving. But if we increase the tension to 12 newtons, it will start moving at an acceleration of 2.48 meter per second square. So let's check what happens when we change each variable. So if we increase the tension in the rope, it will increase the acceleration because there will be more horizontal force and less friction because t sine theta will reduce the normal force. And if we increase the mass, it will have more inertia, so less acceleration. And also increasing the mass will increase the friction because it will increase the normal force. In addition, increasing the static friction will make it harder to start moving, and increasing kinetic friction will make it have smaller acceleration once moving, as you can see here. So if we keep all values the same, but we change the angle at which the rope is pulling, you can see that the optimal angle that gives the maximum acceleration is around 20 degrees.